Good afternoon, everyone. How are you all? I hope everybody is in the pink of health and happiness. So, in today's class, we are going to learn about excretory product standards and their elimination. As always, we are going to start with PYQs. With that, we are going to learn the respective topics. So, shall we start? Can I get a quick thumbs up so that I know everybody is ready to begin the class? Yes, Kiran, Sanjay, Sakshi. Thank you so much. So, let us begin. The first question of today is, choose the correct statement given below regarding the juxtamedullary nephron. So, we need to find a correct statement. Always, whenever you get the correct incorrect thing in the question, underline it, always underline it, okay. So, that we need to know whether we should be finding the correct answer or the incorrect one. About the juxtamedullary nephron. So, what is juxtamedullary nephron? You know it, right? The nephron which is deeply embedded into the medullary pyramid. If this is a loop of Henle, this is loop of Henle, and this is a Bowman's capsule, PCT, DCT, and collecting duct. So, this is juxtamedullary. Medullary comes means it is deeply embedded into the loop of Henle is very much deep into the medulla. This is called juxtamedullary nephron. So, which is the correct answer now? The loop of Henle of juxtamedullary nephron runs deep into the medulla. Yes, we got the answer. It runs deep into the medulla. So, this is loop of Henle of juxtamedullary nephron runs deep into the medulla. So, we will see the next why it is wrong. B, C, D and D. Juxtamedullary nephrons outnumber the cortical nephrons? No, actually cortical nephrons are about 80%. Okay, 80%, 80 to 85, manlo 80 to 85% are cortical nephrons, and juxtamedullary are 15% to 20% of total nephrons. So, B is wrong. Juxtamedullary nephrons are located in the columns of Bertini. No, what is columns of Bertini? The space which is outside here medulla, that is called columns of Bertini. Actually, they are embedded into the medullary pyramid. So, not into the columns of Bertini. Actually, they are located in the cortex. I mean this part DCT, Bowman's capsule, then glomerulus, then PCT, everything is in the cortex plus medulla. Cortex plus medulla. The renal corpuscle of juxtamedullary nephron lies in the outer portion of the renal medulla. No, actually where this part where it lies, actually it lies in the cortex. So, which makes this statement also wrong. So, what is the right answer here? The right answer is A. A is the right answer. Following everybody? Understood? Yes. Thank you. So, question number 2. Given below are statements, one is labeled as assertion and another is labeled as reason. Assertion: nephrons are of two types, cortical and juxtamedullary, based on their relative position in the cortex and medulla. Yes, correct, right? Just now we discussed about it. So, we discussed about juxtamedullary, which means they are deeply, if this is the medullary pyramid, the juxtamedullary nephrons will be deeply embedded like this. This is a collecting duct, and the cortical nephrons, how they will be? They will be not deeply embedded like this. They will be small, like only this much. Understood? So, there much of the portion will be seen in the cortex, that is cortical nephrons. True. The juxtamedullary nephrons have short loop of Henle. Nay, see, this is long, right? Long loop of Henle, long, very long. It is deeply embedded. Whereas cortical nephrons have longer loop of Henle. No, it has short. Which makes reason as wrong. The reason is wrong here. The reason is wrong. A is true, R is false. A is true, R is false. D for Delhi is the right answer. Understood? Going for the next question. Easy question. Just tell me the answer, children. Give the answer to this question. Okay, question reads, nitrogenous waste is very good. Okay, we will read the question. Nitrogenous waste is excreted in the form of pellet or paste. Pellet or paste, what it is actually? It is a type of uricotelic organisms do that. Uricotelic organism excrete the nitrogenous waste in the form of what? In the form of uric acid. What are those animals? Just tell me. Examples are reptiles,
frogs,
birds, yes, insects, that is terrestrial insects. Frogs comes in. Amphibian, what type of are they? Then snails. So these are the types actually excrete their nitrogen waste in the form of uric acid. Those are called uricotelic organism. Birds. See, this one is actually egg-laying mammal, echidna, platypus. Yes, this is platypus. So this is a mammal. Salamander is a amphibian, and hippocampus is a fish, marine, but it is bony. So how do these secrete the nitrogenous waste? This is urea. Bony fish, bony fish is which type? Sorry. Bony fish are amniotic. Then salamander, amphibians, they are also urea, right? So pavo is a peacock. Which means this is in the form of pellet and paste, that is uricotelic. In mammals, which blood vessel would normally carry largest amount of urea? Tell me which one it is. Which one? Is it renal vein? What is renal vein? The vein which is coming out of the kidney. Renal vein. Okay. One is renal artery. This one is renal vein. Anyway, why the blood is going here, filtration is taking place and it is coming out. Anyway, this will be having the least amount of urea, right? So which means not this. Dorsal aorta, it will be having particular concentration of urea, but not, we need to find the largest amount of urea. Definitely dorsal aorta will not be having. Hepatic vein in the sense, this one means liver, okay, the liver, the vein coming out of the liver, okay, hepatic vein. So what happens in the liver? In the liver, ammonia is converted to urea, okay. There is something called urea cycle takes place. There is a urea cycle, okay, urea cycle. Ammonia is converted to urea here, and from there this urea will be dumped into the blood. So anyway, definitely if we see, hepatic vein will be having the highest concentration of urea in the whole body, isn't it? Definitely. And hepatic portal vein, what do you mean by hepatic portal vein? From the intestine, this is intestine, okay. Hepatic portal vein is going to the liver. This will be having most of the absorbed digested materials like nutrients in this, isn't it? So it doesn't contain largest amount of urea. There will be certain but not much. Here we can say that C, that is hepatic vein, has the largest amount of urea present. This is a really good question. Can everybody see? 1 second, I will just check. Yes. Tell me the answer. What is A? A is a adrenal gland. A is a adrenal gland. What is B? Here, this position they are asking. B is pelvis. What is C? C is cortex. D is D is cortex. C, they wanted medulla, I think. Medulla, anyway. You see here, outer region they are asked. This is cortex. Tell me the answer. D is cortex. Yes, D is cortex. Outer part of the kidney and do not contain any part of nephrons. Any part of nephrons. Which part of nephron is can we see in the cortex? Tell me. Tell me. See, definitely we see the nephrons, especially the Bowman's capsule, glomerulus, then PCT, DCT, everything which is there is we can see in the cortex. Definitely this is wrong. A is adrenal gland located at the anterior part of the kidney. Yes, it is above the kidney. This part. This is the adrenal gland. Adrenal. Ad means adjacent, which is near. Ad means near to the renal kidney. Adrenal, which is adjacent, that is near to the renal part. Renal means kidney. That is adrenal gland. Name itself suggests what is adrenal. Located in the anterior part of the kidney, yes. Secrete catecholamines which stimulate glycogen breakdown. Yes. And B is pelvis, broad funnel shaped space into the inner to the hilum. Yes, this part is hilum. Starting this part is hilum, inner to the hilum. Directly connected to loops of Henle? No. Loop of Henle is in the medullary pyramid. It doesn't connect with any, it doesn't even come near to the pelvis. So this is wrong. C is medulla, inner zone of the kidney and contains complete nephrons. No. It contains only loop of Henle. Loop of Henle's. Only this it has. So we get B. We need to find why this is marked. Okay. The answer is B for Bombay is a correct answer. Understood? Any doubts? Any doubts, students? We are going for the next question. Given below are two statements. Urine formation and functions of tubules. We got into the topic of urine formation and functions of tubules. Question number 6. Given below are two statements. Statement 1. In the nephron, the descending limb of loop of Henle impermeable to water and permeable to electrolytes. So this statement is wrong because descending loop of Henle is permeable to water and impermeable to electrolytes, descending one, isn't it? So if you see Bowman's capsule, if we see the functions of tubules, here we can find right. Here we can find this is afferent arteriole, this is efferent arteriole. What is this? This is Bowman's capsule. Bowman's capsule. Here selective reabsorption and secretion happens, isn't it? Now we are going to learn about how the selective reabsorption and secretion happens. Now tell me, what and all the things will be reabsorbed in PCT? This is PCT. What all things will be reabsorbed in PCT? 100% nutrients. 100% nutrients will be reabsorbed back into blood. Then around 70 to 80% electrolytes that is NaCl will be reabsorbed, and almost 80% of water will also be reabsorbed in PCT. Secretion of what and all takes place? Secretion of potassium ions, secretion of ammonia, secretion of H plus ions takes place in PCT. Now coming to the descending loop of Henle. What happens? Descending loop of Henle, reabsorption of water takes place. Reabsorption of water. So which means the descending loop of Henle is permeable to water. If it is permeable to water only, the water can go out, isn't it? The water can go out. If this is permeable to water. This is ascending loop of Henle. Ascending means going up. Ascending loop of Henle. This is permeable to NaCl. Then coming to DCT, again whatever the left things like conditional reabsorption here of water, then sodium ions, that is NaCl you can say, then bicarbonate ions, again here also reabsorption of bicarbonate also takes place, bicarbonate. So these things takes place. Again the secretion of same things, that is K plus, ammonia and H plus, excessive of these will be secreted in. Now coming to the collecting duct, this is the collecting duct. Again in the collecting duct, excess of water which and all will be there, again it will be reabsorbed, water will be reabsorbed. Again if there is any K plus, that is potassium ions, excess then is H plus, that is hydrogen ions, that will be again secreted into the collecting duct. The urea for osmoregulation, the urea can be again, if it is required, the urea for osmoregulation will be going back into the loop of Henle here in the ascending one, just to maintain the osmoregularity. This can be happening. So these things will be happening in the nephron. Understood? So here just read again, in the nephron, the descending loop of Henle is impermeable. No, it is actually permeable to water and impermeable to electrolytes, which means this statement is wrong. The proximal convoluted tubule is lined by simple columnar brush border. Is it columnar? No, it is cuboidal. This is cuboidal cells, cuboidal epithelial cells. So this also makes this statement wrong. This statement you can see in structural tissue lesson, okay, structural organization. So this is actually the nephrons, the lining of the nephron is cuboidal cells, not the columnar cells. So makes this statement also wrong. Statement 1 and 2 both are false. So D for Delhi is the right answer. Understood? And this, what I explained it here, is very, very important. Understood, students? You can make a note of it. So can we move to the next questions? In the coming questions, we will be requiring that particular information. Ascending loop of Henle is impermeable to water. Yes, it is impermeable to water and permeable to salt, that is NaCl. Allows transport of electrolytes actively or passively? Yes, correct, actively or passively. Actively, this one, transport, the active transport will be Na plus ions will be actively transported and Cl minus will be passively transported. The dilution of, okay, this assertion is because the dilution of filtrate takes place due to efflux of electrolytes in the medullary fluid. Yes. So if we go back to this particular thing, so anyway, here NaCl is actively and passively it is transported. So ascending loop of Henle is permeable to NaCl, because as if you see these NaCl, that is solute concentration, solute is going out of the loop, can we say the concentration decreased here? The concentration of NaCl decreased, isn't it? Which means concentration decreased, in a sense the dilution increased. So can you see the dilution of filtrate? The dilution can take place. Here the concentration of, as if you, for example, you are making a lemon juice, you have squeezed one extra lemon, then what do? You cannot take the lemon back as you have already squeezed it, isn't it? But you can add more water to dilute it, isn't it? But here ulta, you can take the lemon out. If you take the lemon out, anyway concentration decreases. Jitna lemon chahiye tha utna nahi. You can take the lemon out here. If you took the lemon out, anyway concentration decreases, which means anyway diluting. That is the meaning of this sentence. So this is also correct. Yes. Is it correctly explaining? Yes, it is definitely correctly explaining. Ascending loop of Henle is impermeable to water and allows the transport of electrolytes actively or passively. Yes, because dilution of filtrate takes place due to the efflux of electrolytes in the medullary fluid. Understood? So both A and R are true and R is the correct explanation of A. So C is the right answer. I hope everybody is following. Any questions, any doubts? Any questions, students? I hope no. Yes. So coming to the next question, which of the following statement is correct? We need to find the correct statement. The ascending loop of Henle is impermeable to water. The ascending one is impermeable to water. This is true. We need to find the correct. Yes. The descending loop of Henle is impermeable to water. This one. Actually it is permeable to water. Impermeable nahi. And the ascending loop of Henle is, anyway we got the answer, we are just checking the other. The ascending loop of Henle is permeable to water. The descending loop of Henle is permeable to electrolyte. Here it is only water, no electrolyte. So it is impermeable to electrolyte. So which means this is also wrong. A is the correct answer. First, see, as I told you, even if you get the answer in the first statement itself, just go through the three other. The part of nephron involved in active reabsorption of sodium ion is, which one? Anyway, the sodium ions were reabsorbed actively in proximal convoluted tube also, distal also, and ascending loop of Henle also. Now tell me which one. Reabsorption was happening. Whether it is actively, conditional, whatever it is, now you tell me. B. अरे डिसेंडिंग लूप ऑफ हेनली में तो एब्जॉर्प्शन ही नहीं हो रहा था ना. Oh, we need to find wrong state. No, the part of nephron involved in active reabsorption of sodium. But B कैसे हो सकता है बताओ. क्योंकि descending loop of Henle में तो that is impermeable to NaCl. It is only permeable to H2O. तो descending loop of Henle तो definitely wrong है. If it is ascending loop of Henle, somehow we could consider, but descending loop of Henle ना. B तो definitely wrong. Okay. Now coming to distal convoluted and proximal convoluted. इन दोनों में कौन है? In distal convoluted what happens? Conditional reabsorption happens. Conditional reabsorption. Here active reabsorption. Active reabsorption. Around 80% of all the electrolytes will be actively reabsorbed in proximal convoluted tubule. Understood? So it is D4 Delhi is the correct answer. Understood? Here though definite descending, this is descending loop of Henle. Descending loop of Henle में no. Understood? Bowman's capsule में भी नहीं. We need to reabsorption where the reabsorption starts in PCT. 80% of electrolytes will be reabsorbed in PCT. 100% of nutrients will be reabsorbed in PCT. Most of the bicarbonate ions will be reabsorbed. NaCl will be reabsorbed. Everything. And secretion means you are adding into the loop of Henle. You are adding into the tubules. What are you adding? Secretion of potassium ions, hydrogen ions, that is H plus, and ammonia. Only these three will be secreted in. Otherwise, everything else will be secreted out. Excess of these things. Understood? Removal of proximal convoluted tubule from the nephron will result in. Tell me, easy question, easy, very easy. The removal of proximal more concentrated. देखो इतना पार्ट proximal convoluted tubule यानी ये वाला पार्ट. ओके. ओह सॉरी. No, that is the wrong answer. That is the wrong answer. So this part is proximal convoluted tubule. If we remove this part, proximal convoluted tubule ko, if we remove this part, then what happens? 100% nutrients इधर ही रह जाते हैं. Electrolytes, most of the electrolytes इधर ही रह जाते हैं. वो H2O इधर ही रह जाता है. Means it is going into these things. It is going into these things, which means concentrate. Actually, this is when these things are coming out, reabsorbed back into the system. अभी concentration हो रहा है ना? Concentration of urine happening. क्योंकि 1 minute, in 1 minute, how many ml will be filtrate? What is the filtrate here? 125 ml per minute. 125 ml per minute is the filtrate from the glomerulus into the Bowman's capsule. Understood? So एक दिन में कितना हो गया? 180 liter. 180 liter of urine. Anyway, nobody is excreting 180 liter of urine because everything is most of the things, necessary things are reabsorbed back. अगर यहाँ इस part को हम निकाल रहे हैं, then is the concentration happening? Tell me. मोर कॉन्सेंट्रेटेड यूरिन कैसे? मोर कॉन्सेंट्रेट नहीं हो सकता. ओके, नो चेंज इन द क्वालिटी एंड नो, बहुत सारे उधर ही रह जाते हैं ना. नो यूरिन फॉर्मेशन, यूरिन फॉर्मेशन तो होगा, मोर डाइल्यूटेड यूरिन, बिकॉज द न्यूट्रिएंट्स यूरिन में ही रह जाता है, इट इज़ नॉट रीअब्सॉर्ब बैक. देन द बाइकार्बोनेट, वाटर, then NaCl, many things. I mean, especially the water reabsorption. 80% कहाँ reabsorbed, और 80% of water here is reabsorbed in PCT. PCT को ही हटा रहे हो, then water will be retained in the filtrate. The water will be retained in the filtrate. जब water filtrate में है, then it is more diluted. Understanding? Understood or not? Yes, Kiran, Sakshi, I hope you understood. Okay, so जल्दबाजी मत करो when you are giving answer. We have to think, time लो, because 1 minute per question ले सकते हो तुम. अगर तुम्हें लग रहा है कि थोड़ा डिफिकल्ट है, I have to read the question properly, you can take 1 minute is there. You don't, because 4 marks, it has 4 marks. इतना ईजी है, ऐसे इट इज़ ईजी. 4 मार्क्स यूं ही मिल जाते हैं. सुरभि, योर माइक इज ऑन. ओके, so this is the thing. I hope you understood. Which of the following does not favor the formation of large quantities of dilute urine? So tell me, which of the following does not favor? We need to find it does not favor the formation of large quantities of dilute urine. Atrial natriuretic factor is a vasodilator. If this is a vasodilator, then yes, dilute urine will be formed. Dilute urine. Alcohol, actually, when people consume alcohol and more caffeine, that is coffee, you feel like more urination, right? More dilute. So the urine become more dilute. So ANF, that is atrial natriuretic factor, alcohol, caffeine, actually gives more dilute urine, frequent urination. More dilute means frequent urination. Frequent urination. Frequent urination मतलब more dilute ही है. Renin, what it does? It is in the RAS mechanism, right? For regulation of quantity of urine, isn't it? So what does renin does? Renin actually converts angiotensinogen to angiotensin 1, angiotensin 2. This angiotensin 2 will stimulate the adrenal cortex to produce aldosterone. Ultimately, it concentrates the urine, isn't it? It increases the GRF, glomerular filtrate rate, GFR, and it concentrates the urine definitely. Reabsorption of water takes place. Reabsorption. So definitely it concentrates the urine. Here we need to find which one is the does not favor the large, that is renin definitely. Understood? Because here concentration of urine is taking place. Concentration of urine. Any doubts? So you want me to explain the this one, the regulation of kidney function, or shall we continue solving the question? Tell me, children. We can go through RAS mechanism, antidiuretic factor, then ANF. If not, we'll continue solving the question. Mechanism of concentration of filtrate, regulation of kidney functions and mixturation. Okay. So, diuresis is prevented by, diuresis means like dilute urination, dilute, more urination or more this thing. So, what is it is prevented by which? Tell me. Renin from JG cells via switching off the osmoregulator. Switching off kaise? If there is a diuresis, the JG cells, the osmoregulators will be switching on. ANF from atria, that actually dilute it. It is a vasodilator, right? It is a vasodilator. Vasodilator. Aldosterone from adrenal medulla. Aldosterone from adrenal cortex. Adrenal medulla will be releasing, secreting what? Nephrin, epinephrine, or adrenaline or noradrenaline, you can tell. So, aldosterone is secreted from adrenal cortex, not medulla. Vasopressin from neurohypophysis. Yes, that is posterior pituitary. Posterior pituitary. Vasopressin actually is stored in the posterior pituitary and it will be released, which means diuresis will be prevented. Vasopressin, otherwise it is also called ADH, anti-diuretic hormone. Anti means reverse of diuresis, anti-diuretic hormone. So, it actually stops or prevents the diuresis. Anti-diuretic hormone prevents the diuresis, that is vasopressin. Easy. So, D for Delhi is the correct answer. Given below are two statements. Statement 1, concentrated urine is formed due to counter current mechanism in nephron. Yes, concentrated urine is formed due to counter current mechanism in nephron. Yes. The counter current mechanism helps to maintain osmotic gradient in the medullary interstitium. Yes. Both the statement correct. Counter current mechanism helps in maintaining osmotic gradient in the medullary interstitium. Yes. So, both the statement correct. Both 1 and 2 are correct, which means C is the correct answer. Everybody having a good knowledge about counter current mechanism, give a quick thumbs up. Or if you have any doubt regarding counter current mechanism. Yes, Surabhi is, well, she knows it. The rest, Sakshi, Kiran, do you know it? Kiran doesn't. Okay, we'll go through the counter current mechanism first. We will go through the counter current mechanism. So, what is counter current mechanism? What is counter current mechanism is, if this is loop of Henle, if this is loop of Henle, and we can see the vasa recta here, isn't it? The descending loop of Henle, this is descending loop of Henle, which means in which direction the urine is flowing? In this direction. Here ascending in this direction. Before that, I will tell you, wait, I will draw the neuron here, sorry, nephron here, I am really sorry, nephron here. This is nephron, and if I have to draw the blood vessels, here this is afferent arteriole, this is efferent arteriole. Okay, this you can see, this is the vasa recta. This is the vasa recta. If you can see, what is the flow of blood here? Direction? This direction, right? It is flowing in this direction. In this direction. Can you see? This is flowing in this direction. Which means, here, in the descending loop of Henle, the urine is flowing in this direction, and the blood here is flowing in this direction. So, one is downwards and another one is upwards. Can you call this as counter current? One is flowing downwards, another flowing upwards. If you see here, the urine is flowing upwards here, like this, in this direction, but the blood is flowing downwards. The urine is flowing upwards, the blood is flowing downwards. Can you call it as this also? When it comes to ascending loop of Henle and this vasa recta, the descending of vasa recta, this is also counter current. Also, if you see this one, descending loop of Henle, ascending loop of Henle, one is going down, another one is going up. Can you call it as counter current with respect to these two? Yes. With respect to vasa recta here, this is going down, this is going up. Can you see with respect to these two? This is also counter current. One is going down, one is going up. This is very much required. I'll tell you why it is required. So, this is blood vessel. This is loop of Henle. We have already studied the loop of Henle. It is, the descending loop is permeable to water. The water is going out. So, the water whichever is going out is immediately taken up by the vasa recta which is present here. The vasa recta, the direction of the vasa recta here is this direction. Here it is this direction. Okay. Here it is going down. As when these things is happening, for example, here the water went out. The concentration increased. Here also water went out. Concentration increased. The water went out. Concentration increased. If you see here, from here, if you see for like this, here also the water is coming out, so concentration started increasing. So here in the starting, in the cortex, it was before 300 milliosmol per liter was the concentration. Water came out. Okay. So Nimbu, you were doing the lemon juice, right? So you need to concentrate it. You need to concentrate the juice. You are taking the water out, so that only lemon will be there. If you take the water out, only the lemon will be there inside, which is concentrating. It is getting concentrated, right? So water came out. So it became 600 milliosmol per liter. Again water came out 900 milliosmol per liter. Again water came out 1200 milliosmol per liter. So at the end here, if you see at this particular concentration, is this particular part of the loop of Henle, there will be maximum concentration of urine, okay, which means previously it was 300 into 4 is 1200, which means the concentration of urine became around 4x, right? The concentration became around 4x. It was in the medulla, in the cortex it was 300, and when it come to deeper into the medulla, it becomes 1200. Okay, again when it is the ascending loop of Henle, it is permeable to NaCl came out, reabsorption of NaCl. Okay, how it got reabsorbed? It reabsorbed within close proximity there is a blood vessel. The NaCl will be getting into the blood vessel. So now you are taking out the lemon from it. Previously you took out the water which increased the concentration. Now you are taking out the lemon which while going up, which means it is decreasing the concentration. When you took out the water, it was 1200 milliosmol per liter. When you took out lemon, I am just giving the analogy, you took out the NaCl, okay, you took out the NaCl, again it became 900 milliosmol, then again you took out the NaCl, it becomes 600, again you took out. When you reach this one DCT, it will be 300 milliosmol per liter, and again this is DCT, okay, this is DCT. Again if you see here, you can see the collecting duct here. The collecting duct is also deeply embedded into the medulla, which means again when I was explaining you about this one function of tubules, I told you again the water is coming out, again the water is coming out, again you are taking the water from the nimbu sharbat, that is lemon juice, again you are taking, which means again it is getting concentrated, here, again you are adding K plus, again you are adding H plus, so again which is actually putting into concentration. Again the solute concentration is increasing only here, at the end here again it will be 1200 milliosmol per liter will be the concentration. Understanding? For example, when I was teaching you that same thing, the function of tubules, I said the urea if needed is taken back to the ascending loop of Henle for maintaining osmoregulation. For example, anyway 1200 nahi gaya wo, adding urea, this will be the highest concentration here, right? Again we are taking the urea from here and adding it here, which means we need to make it topmost concentration into the medulla here into the medulla. So this is about the countercurrent mechanism. Understood? Yes. Thank you so much. So we were discussing this, right? Yes. So again you solve this question statement, concentrated urine is formed due to the countercurrent mechanism. Yes, from like previously, like it was in the cortex it was 300 milliosmol per liter, in the medulla, deep into the medulla it became around 4x concentrated, that is 1200 milliosmol per liter. So this is correct. Countercurrent mechanism helps in maintaining osmotic gradient in the medullary interstitium. This is also correct. So both the statement A and B is correct. Now try solving question number 14. Which of the following statements are correct? An excessive loss of body fluid from the body switches off. Is it switches off? Switch on the osmoregulators, nahi? So A is wrong. Need to find the correct statement. A is wrong. ADH facilitates water reabsorption to prevent diuresis. ADH, it prevents the diuresis. How it prevents? It actually facilitates the water reabsorption. True. ANF causes vasodilation. ANF is a vasodilator. Definitely it causes vasodilation. What do you mean by vasodilation? Vaso means vessel. Okay. If this is a normal size of a blood vessel, if ANF is released, then it actually dilates the blood vessel. So this is called vasodilation, and ANF does that. It is true. ADH causes increase in blood pressure. Yes. How does it cause increase in blood pressure? Anyway, if this is a blood vessel, reabsorption of H2O is taking place. Reabsorption of H2O is taking place. It increases the volume here, but same the blood. Whether when increases volume here, when increase the volume here, then definitely it causes the blood pressure to increase. Definitely. Also in the afferent arteriole, it constrict as it's a vasoconstrictor. Vasoconstrictor. Also, it constricts the blood vessel. When the volume decreases, pressure anyway increases here. If this is a usual size, now if it constricts the blood vessels, what happens? The blood pressure increases. ADH is responsible for decrease in GFR. ADH is responsible for increase in GFR. Increase in glomerular filtrate rate. See, ADH released, vasoconstrictor. This one, ADH is also called as vasopressin. Vasopressin means, vaso means blood vessel, pressin. Press kiya. Okay, which means it increases the blood pressure. When it increases the blood pressure, whatever there inside, the filtrate rate will be more, right? Itna chota kiya, then whatever inside, the filtrate rate will be more. If this is a this one, Bowman's capsule, the filtrate rate, GFR increases. ADH responsible for decrease? No. Which means we need to find the correct answer. BCD is the correct answer. BCD. Statement BCD, that is C is the correct answer. Otherwise, with elimination technique also you can eliminate it, like A nahi hai, then E bhi nahi hai. If you know if you know that A and E are definitely false, with the elimination technique also you can say that C is the right answer. So statement based question में वो एक plus point है. With elimination technique you can mark the answer. Arrange the events of renin-angiotensin mechanism in correct sequence. Now arrange, children. Arrange. Let me see. Sakshi, Surabhi, Kiran. Arrange it. Arrange. So activation of JG cells and release renin. Yes, activation takes place in the primary stage. Yes, angiotensin 2 activates release of all cells. Okay, fall in the the first one is fall in the glomerular blood pressure or GFR. Fall in the GFR. So this will be the first option. If we see the first option, we heard the answer with the starting. Yeah, A is the correct answer. So fall in the glomerular blood pressure, which activate the JG cells and release renin. Where the JG cells are present, tell me, where the JG cells are present? For example, if this is the afferent arteriole and this is efferent arteriole. This is the Bowman's capsule. The JG cells are present here. And again in the DCT. Here itself they get to know that there is a fall in the glomerular blood pressure. If there is a fall in the blood pressure, they will get to know here itself. Okay, here where the JG cells are present in the afferent arteriole and in the DCT. So JG cells, okay, JG cells. When these are this one what receptors, they'll get to know, they'll receive the signal that there is a fall in the glomerular blood pressure. Immediately what they do, these JG cells secrete renin. These JG cells secrete renin. What this renin does, this whole total we call it as the RAS mechanism. Okay, RAS mechanism. I'll tell you what it is. JG cells release renin. The renin convert the inactive form of angiotensinogen 2, angiotensin 1. From here, angiotensin 1 will be immediately converted to angiotensin 2. Angiotensin 2, what it does, it gives the adrenal cortex the message to release aldosterone. What this angiotensin 2 aldosterone, what they do, they actually, one thing, these are vasoconstrictor. They constrict the afferent arteriole, all these things, glomerulus, they constricted, everything will be. So when this constriction of blood vessel happens, it increase the filtration rate. This increase the filtration, which means GFR increased. GFR in turn increase the reabsorption of water back into the system. Understood? It reabsorption of water back into the system. When the water is reabsorbed back, you can see the concentration, the urine concentration increasing in the urine concentration, which means it is not the diluted urine now, it is a concentrated urine. All the water is actually reabsorbed back into the system. Understood? So that is renin, angiotensin, aldosterone system, that is RAS. This is one of the mechanism for concentration of urine. Understood? And also the regulation of kidney function. Okay, I will just repeat it. The JG cells which is present in the afferent arteriole and on the DCT, it produce renin. Renin produce convert angiotensinogen. This is in the inactive form to the active form of angiotensin 1. Angiotensin 1 will be converted to angiotensin 2. Angiotensin 2, what it does, it gives the signal to the adrenal cortex to release aldosterone. This aldosterone increases the GFR, also it increases the reabsorption of H2O, also it increases the conditional reabsorption of H2O from the DCT also. Conditional reabsorption of water also takes place from the DCT. Conditional reabsorption also, please make a note of it, conditional reabsorption. Okay, now just mark the answer. C. Then activation of JG cells and release renin is 2. Renin will, angiotensinogen is converted to angiotensin 1 and then to angiotensin 2. This is 3. Then angiotensin 2 activates the release of aldosterone. aldosterone. From where aldosterone is released? Adrenal cortex or adrenal cortex. And what it does? Reabsorption of Na plus and water from the DCT. DCT takes place. That too conditional reabsorption. Conditional reabsorption takes place. So this is the fifth one. C, A, E, B, D. Understood? Understood? So we are going for the next question. Select the correct statement. Angiotensin 2 activates the cortex of adrenal gland to release aldosterone. Tell me, is it right or wrong?
Right.
Right. Aldosterone leads to increase in blood pressure. Yes. Vasoconstrictor है वो भी. ANF acts as check on renin angiotensin mechanism. Yes. So these things happening, right? These things, what in the previous slide I explained this. Who will be checking, putting a check on these things? For example, first there was a low in GFR rate. It was low. Now RAS mechanism आया. Now the GFR rate increases. Fine, right? Now we need to put a check on it. Telling, okay, stop doing it. We are all right. We are set to what it was for normal. Who will put this check? Actually, ANF. ANF will put the check on the renin angiotensin mechanism. So C is also true. ADH cause vasodilation. ADH नाम क्या है उसका? It's a vasopressin. It's a vasopressin. Vasopressin means it is a constrictor, not dilator. ADH doesn't cause vasodilation. Who causes vasodilation? Actually ANF. ANF put the check on angiotensin. How it will put the check? Vasodilation. Vasodilation. ANF is a vasodilator. ADH is a vasoconstrictor, which means D is wrong. Vasopressin is released from adenohypophysis. Is released from neurohypophysis. What do you mean by that? Posterior pituitary. Posterior pituitary. Understood? It is posterior pituitary, which means D and E are wrong. Need to find the correct statement. That is ABC. Elimination हो सकता था क्या? अगर E पता है wrong, then this could have, you need to know both wrong. Anyway, with our knowledge we could say that A is wrong. Sorry, A is correct, which means A, B, C are the correct statements and D and E are wrong statements. Select the correct statement. Angiotensin 2 is a powerful vasodilator. बताओ. Angiotensin 2 is a powerful vasodilator और vasoconstrictor. Vasoconstrictor कौन कौन है? Angiotensin 2 is a vasoconstrictor. Aldosterone is a vasoconstrictor. ADH is a vasoconstrictor. Isn't it? Angiotensin 2 is a give the answer to this question, children.
C.
Okay. So this is wrong. Countercurrent pattern of the blood flow is not observed in vasorector. Why? It is observed, right? If this is a vasorector, this is going down, this is going up, right? So this is wrong. A reduction in glomerular filtration rate activates the JG cells to release renin. Definitely C. Who gave that answer? Very good. Atrial natriuretic factor increase the blood pressure. actually what it does, tell me? Vasodilator. It decrease the blood pressure. ANF decrease the blood pressure, not increase the blood pressure. Understood? This is wrong, which means C is the correct answer. Very good, children. The increase in osmolarity from outer to inner medullary interstitium is maintained due to increase in the osmolarity from the outer to inner. So that is countercurrent mechanism. Tell me the right answer. We need to find the right, yes, countercurrent mechanism ka. Close proximity between Henle's loop and vasa recta definitely aids for countercurrent mechanism. Varna kaise hota? Countercurrent mechanism directly given, yes. Selective secretion of HCO, this is HCO3 minus, okay? No, sorry, HCO3 minus. So selective secretion of secretion. Tell me, bicarbonate is secreted or reabsorbed? The bicarbonate is secreted or reabsorbed? And hydrogen ions are in PCT. What and all things are? It is reabsorbed. Kiran, very good. So anyway, which means this is wrong, right? This statement third is wrong. High blood pressure in the glomerular capillaries. Okay, high blood pressure, this statement is right, but we need to find the increase in osmoregularity. We need to find the statement regarding to the countercurrent mechanism. High blood pressure in the glomerular capillaries, is it anyway aiding to the countercurrent mechanism? It is not aiding to the countercurrent mechanism. Anyway, it is not helping in any way in the countercurrent mechanism, isn't it? But indirectly help कर रहा है, लेकिन directly नहीं, which means only 1 and 2 are correct. Understood? Only 1 and 2 are correct. That is C is the correct answer. High blood pressure in the glomerular capillaries, the filtration, the GFR increases. When the GFR increases, reabsorption also increases. When reabsorption increases, anyway the concentration, urine concentration increases. So everything is happening here, but we need to find the increase of osmoregularity from the outer to inner medulla. वो वाला था ना, that I told you, this one, from 300 milliosmol to 1200 milliosmol कैसे हुआ, क्यों हुआ, वो हमें बताना है. That is 1 and 2 are correct. Understood? Any doubts? Which of the following factors is responsible for the formation of concentrated urine? Again, okay, tell me. Low levels of antidiuretic, formation of concentrated urine बनाने के लिए low levels of antidiuretic hormone, ADH की ज़रूरत है for formation of concentrated urine, isn't it? Antidiuretic, diuresis means diluted urine, antidiuretic means concentrated urine. We need to have particular levels of ADH, which means this statement is wrong. Maintaining hyperosmolarity towards the inner medullary interstitium in the kidneys. Yes, true, for concentration of urine, yes, because it gives 4x concentration, right? The secretion of erythropoietin by juxtaglomerular complex. Erythropoietin, what erythropoietin does? Production of RBC. Production of RBC. Why production of RBC is coming into the picture here for concentrated urine? Hypostatic pressure during the glomerular filtration. It is also required for anyway, like not direct responsible. Hypostatic pressure, what it does? Glomerular filtration rate increases. Same thing, if glomerular filtration rate increases, reabsorption increases. If reabsorption increases, concentration urine takes place. But it is aiding, it is helping in, but not the direct one. The maintaining osmolarity towards the inner medulla. Countercurrent mechanism चाहिए हमें. That is B for Bombay is a correct answer. We need to find the correct answer. Yes. B for Bombay is a correct answer. This is also aiding. Hypostatic hydrostatic pressure during the glomerular filtration. It is required because it is aiding, na? It is aiding in the GFR, increasing the GFR rate. Ultimately, it will be, the concentration will be increasing, but in an indirect way. Match the following. Is this clear? I mean, can you see this particular thing here? Match it. Ultrafiltration. Ultrafiltration takes place in the glomerulus. Glomerulus. Where is it? Okay, here it is. The Malpighian corpuscle. What do you mean by Malpighian corpuscle? That is glomerulus plus Bowman's capsule. Total, whole total, we call it as Malpighian corpuscle. Concentration of urine. Concentration of urine takes place in the Henle's loop. Transport of urine. Ureter. Storage of urine. Urinary bladder. So, A4, B1, C2, D3, which means B for Bombay is a correct answer. Decrease in the blood pressure or volume will not cause the release of, decrease in the blood pressure will not cause the release of, decrease in the blood pressure or the blood volume will cause the release of renin, will cause the release of aldosterone, will cause the release of ADH, will not cause the release of atrial natriuretic factor, otherwise we call it as ANF. Itself is a vasodilator. This is the 100th time I am telling you this. So, which means anyway it is decrease in the blood pressure. Why will it again releasing of ANF will decrease the blood pressure again? It will not take place. Body has its own mechanism, yes. Which means B is the correct answer. B for Bombay is the correct answer, correct option. It will not cause the release of ANF because ANF itself is a vasodilator. Why will it again cause the vasodilation? Which of the following does not favor the formation of large quantities of dilute urine? Yeah, we have already once did this, right? Does not favor the, it does not favor. So, this will favor the large quantities, alcohol, caffeine, as I told you. This will give the frequent urination, okay, especially alcohol and caffeine. When you drink alcohol and caffeine, especially coffee. Is there any network issue? Are we facing any network issue? Okay. Yes. So, this cause frequent urination, which means diuresis. These two. Natriuretic factor, vasodilation, it causes diuresis, which does not favor the formation of dilute urine, that is diuresis, that is renin, isn't it? It puts a check on diuresis, renin. So, renin is the correct answer. We need to read correctly. It asks, does not favor. Human urine is usually acidic because, tell me what is acidity basis? You know it, right? What is acidic and basic? Which means H plus ion ज़्यादा जिसमें हो वो acidic है. So, all the way, even in the PCT, in the DCT and in the collecting duct, what were we doing actually? H plus को इतना खूट के अंदर भर रहता है ना, H plus. So, hydrogen ions are actively secreted into the filtrate. Definitely it will cause increase in the pH. Human urine is usually acidic because it is around 6 pH. Okay, pH is around 6. pH is 6. So, Excreted plasma protein, no. Potassium and sodium exchange generate acid, no. Sodium transport exchange one hydrogen ion for each sodium ion periturbal. Actually it is hydrogen ions are actively secreted. The secretion of hydrogen taking place, right? The other secretions are potassium, then NH3, these things. But if you see, the hydrogen is secreted in, secretion of hydrogen is taking place. All the, even in PCT, DCT, collecting duct. So this actually increase the, decrease the pH or increase the acidity. That is, the pH is around 6. That is the main reason for the acidic pH. Which of the following cause an increase in sodium reabsorption in distal convoluted tubule? Tell me. Decrease in antidiuretic hormone levels, ADH decrease होने से, ADH decrease होने से नहीं. Increase in aldosterone levels, yes. Increase in antidiuretic hormone levels, no. Here sodium reabsorption, the selective reabsorption, not selective, conditional reabsorption. Conditional reabsorption of water and sodium ions taking place because of the RAS, that is aldosterone, increase in the aldosterone level, increase in the antidiuretic hormone level, that is for the increase in the concentration. It talks about H2O. And decrease in the aldosterone level, no. So which means it is B for Bombay is a correct answer. Role of other organs, yes, tell me this question, just try to solve this question. Use of an artificial kidney during hemodialysis may result in, use of artificial kidney, which means it is we are talking about the dialysis procedure. Nitrogenous waste build up in the body? No. What dialysis is? Actually it is removing the nitrogenous waste from the body. It does not build up, actually it removes. You need to find the most appropriate. Okay, this is wrong. Non-elimination of excess of potassium ions? Non-elimination. No, we are removing it, right? It is elimination is taking place. Reduced absorption of calcium ions from the gastrointestinal tract. Actually what happens, no, kidney, many other function of kidney is there. Many other function. What is, one is vitamin D is converted into active form. When it is converted to the active form, the kidney does this. The vitamin D will be converted into its active form. Actually it increases the absorption of calcium from gut, from the digestive tract or the gastrointestinal tract, gut, everything. So it reduces when kidney is not functioning properly. Basically the kidney will do this, increase the absorption of calcium from the gut. When the kidney is not functioning properly, that is artificial kidney in a sense, anyway it is not doing any kind of hormonal things, right? Artificial kidney in a sense, it's only removing the nitrogenous waste and other ions like potassium ions from the body. It is not doing any kind of hormonal things. Reduce the absorption of calcium ions from the gastrointestinal tract, yes, because this is the artificial kidney. It doesn't do any it doesn't secrete any hormone, which means this is correct. Reduce RBC production. What kidney do? Actually it releases erythropoietin. What erythropoietin does? It increase the production of RBC. Production of RBC. Erythropoietin produce the RBC. So kidney secretes erythropoietin like in normal. Does the artificial kidney, that is hemodialysis, the machine, will it secretes the erythropoietin? No, it is anyway not going to secrete the erythropoietin, which means reduced RBC production. This is also true because anyway it is reducing the RBC production because there is no erythropoietin which is secreted. 25 C and D. We need to find the most appropriate, yes, that is C. The option, the statement C and D are correct. Option C is correct. Match the following. It is about the disorders. Glycosuria. Glycosuria means it is the glucose, presence of glucose in urine, sorry, that is presence of glucose in urine. Gout. So A4, we got it. Gout, accumulation of uric acid in the joints. Renal calculi, crystallized salts within the kidney. Oxalates. Glomerular nephritis. Nephritis, in a sense, it is inflammation. Inflammation है तो it is inflammation of glomeruli or glomerulus. So it is anyway with the first match itself we got the answer, that is D4 Delhi is the correct answer. A4, B1, C2 and D3. This was a really easy question. I hope everybody could able to solve the questions, right? I hope everybody understood the concept. So this is the end of PYQs. Just give me a thumbs up there if you understood it. I'll get. Thank you so much. So I hope you understood it, right? Now, did you get the confidence to solve questions regarding this particular lesson? Excretory products and their elimination. Could you able to solve it? I mean, did you get the confidence? Yes, Surabhi, thank you so much. Yes. So that is what required. We need to get the confidence to solve the questions. So that's for today. Okay, I'll meet you in the next class. Till now, take care. Bye bye.